Good morning.
Good morning.
Good morning.
Morning.
Good morning. Oh wait, see that? All right, I'm trying something new this month, but this is I'm trying. I'm so bummed that we're on Zoom. Morning. All right, it's great to see you guys, but this doesn't work. Shouldn't it be putting you guys in the seats? What's the point of this if you're not in the seats? Wait. All right, this is silly. This doesn't work. All right, I'm going to stop this in a second. But good morning. All right, it's great to see you guys. I mean, I hope everybody is safe and warm. Um, of course, it's not like I'm not also relieved to not travel, but I was really looking forward to seeing you guys for real. I can't wait to see you for real next Monday. Okay, I'm going to this is silliness. Hold on a minute. But really, what is is any of you on your side? Do you see any of you in the seats or no? You just see
You're in the seat.
I'm in the
No.
seat. What's the point of that? That doesn't make any sense. All right. Okay, I'm stopping this nonsense. See, I'm just trying to show every semester a little. Okay, I'm leaving. Okay. Hello, hello. No, it is great. Obviously, some of you I know and some of you I don't know. I want to get to know you and I'm gonna get to know you. We're gonna really get to know each other. Um, for real starting next week, but we're going to do a bunch of stuff today. I hope everybody's safe. Okay, and thank you everybody for saying good morning, even though I really appreciate it. All right, so I'm gonna do that. First of all, hello, Gabriella. Hello, Jocelyn. Good to see you both again. Hello, Christopher. I'm looking at visualizations at the moment. Hello, Christopher. Welcome back. Hello, Rebecca. Welcome back. And now I'm looking at the chat. And I know there's a bunch of other people in the room too, but it's harder to tell with the black boxes. So I'm going in the chat now. Hello, Adam. I will make sure you're all here in a second for real. Good morning, Genesis. Welcome back. Good morning, Teresa. Welcome back. Good morning, Angelina. Welcome back. Good morning, George. Welcome back. Oh, this is all right. This is great. I'm so happy that we're all gonna. Okay. Good morning, Gabriella. M. Welcome back. Good morning, morning, Chris. Welcome back. Now, good morning. Now, if I want to be corrected right away, it'll take me a couple of times, but if I mispronounce, if I don't know you yet, and we're all going to get to know each other, whether I know you or not, I will know you. But if I don't know you yet, I apologize. And so therefore, if I mispronounce your name, let me know. So I think it's Brianna. Is that correct, Brianna?
Yes,
Yes,
that's
that's correct.
correct.
Great, thanks. Oh, there's two. Oh, sorry. Okay, so right now, I'm looking at the chat. So there's two. Okay, this is going to be interesting. Okay, they're both pronounced Brianna, but I'm looking at Brianna with a E. Wait, where do I see? I see you in the chat, but that was both. Okay, so good morning, Brianna with an E. We'll have to do something about that. Good morning and welcome back, Rebecca. And good morning, Brianna with an I. Okay, I see you both. Okay, excellent. Good morning and welcome. Good morning, Jacqueline. Welcome. Good morning. Am I saying Camila? No, Camilla. Camilla? Am I saying right? Or maybe we'll find out in a minute. Okay. Good morning, Chanel. Welcome back. Good morning, Veronica. Tell me if I'm saying it correctly, Veronica. Or is it Veronica? No. Okay. And you could tell me in the chat when I say correct me, it could be in the chat, or private chat even. Good morning, Jocelyn. Welcome back. Good morning, Jibo. Welcome back. Good morning, Justin. Welcome. I love the exclamation points.
Good
Oh, yeah.
morning.
Oh, good morning. Oh, and voice. All right. People just got so most of you know. I mean, so I know a lot of you, but and I'm going to try to walk out balance today of like not boring people with. I mean, so a lot of the procedures in Physics 204 are similar to those in Physics 203. I mean, if you have me right. So some of this stuff we're going to figure out as we go. If I ever lose or confuse or frustrate any of you who we haven't met yet, you can't send me direct chat or email or something, and I'll pause and slow down and re-explain things. But I think you'll all pick up pretty quickly. So therefore, what am I saying? I'm saying good morning, Justin, and I'm saying thank you, Camilla, for the confirmation that I said your name right. And I'm saying to all of you, you'll see that each one of you that is participating in any one of these ways, whether it's showing video or putting something in the chat or using your voice, they're all different ways that you're getting points on your grade, which we will explain again today to all of you and be more explicit and clear about than I ever will. I'm going to try to be even more clear about that this semester than last semester. So anytime you're doing these things, maybe even screenshot it because you'll see you're getting points for them. Okay, now I'm looking in the chat. Oh, okay. Thank you, Judith. Got it. Got it. Oh, it is like Veronica. Okay. And it's like Veronica. Got it. Thank you. Okay. Good. So it's like the background of my name too. Okay, got it. Got it. Okay. So as long as I just did all that. So thank you for all the hellos. The hellos matter. I appreciate many of you know that I appreciate the hellos and you get points to them. We'll talk about the points. But now that we've done that, let me actually, so I'm Dr. Yaverbaum. Welcome. You can all see the board, I assume, I believe, right? Okay. Let me because I tend to be a little bit non-linear and I'm going to try to be more linear, like more just moving forward at all times this semester than last semester, something I'm working on. So therefore, let me tell you the goal of today, because I know a double period on Zoom is a lot. We'll either take a quick break. We'll either take a 10-minute break in the middle, or I'm just going to let you go 10 minutes early. We'll see. And by the way, that will sometimes also be true in the double period in the room is also a lot, a double period of physics. I appreciate your courage and energy for signing up for that, but it is a lot. It's less of a lot in person, especially when you participate. It goes faster in person if you participate, but even in the in person, um, we'll either take a 10-minute break in the middle each week, or sometimes we're just going to end 10 minutes early. Okay. Same thing today. The goal of today is that I want to be getting into already starting a solution for you of the first homework before we leave. Like you have a homework that is due a week from today. I'm going to screen share it at some point soon. You have a homework that's due a week from today. I want to have explained enough of the nitty gritty of this course, of the nuts and bolts, especially for people who don't know me. I want to have gotten enough about the syllabus and everything out of the way so that by some point in this double period today, I will start doing the homework for you on the board, showing you exactly what I'm looking for you to give me by next Monday. I'm not going to do the whole thing, and it does get harder and harder, but I will do at least, the first question, um, according to the 5-step method. So I'm going to give you a sample solution of at least the beginning of the homework before we leave today so that hopefully you'll know exactly what I'm looking for you to bring back next Monday. That's the goal, is for me to get into the homework for you by the time we're done today. I've got to get there, but that's the goal, is for me to start the homework for you so you see what's going on and that. But we have to get there. So some just logistical items. I just said hello to many of you, and many of you said hello to me, so I appreciate that. But now let me just be, and that's the way we're going to do attendance. For those of you who know, I don't like do attendance formally, but I take the hellos and the goodbyes very seriously, and that's how I know you're here and all of that. But today, just to make sure we're on the same page, especially because there's a whole I'm going to formally like make sure that I've met all of you. So bear with me for a second. I'm looking at the official Brightspace attendance roster here. Okay. So first of all, so if you can use your voice or chat or voice ideally to respond for a minute, maybe even you could even show video for a second. You'll see too, if you ever show video, you get points for that. And it doesn't mean you have to keep it on. Especially since this is the first day, I would highly encourage you guys to show video for intermittently today. It will help me a lot. It'll help the class be less weird. And we're going to get to know each other anyway. So I would encourage, and if you turn on video, it doesn't mean you can't turn it off. But even for 5 seconds, you do get points for that. So anyway, I'm saying all that to say, Jadine, am I pronouncing your name correct? Oh, there you are. I see you. Oh, awesome. Awesome.
Hi.
Hello. Thank you.
Sounds Jadine, but you could call me Jay if it's easier.
Oh, okay. Jadine or Jay. Okay. It'll take me a couple. Great. Awesome. Thank you and welcome and thank you for sharing. And last question, were you, and I'm not, well, I am going to kind of ask this. I want to get to know everybody. So Jay, did you have Professor Talley last semester? Is that?
No, so I'm actually a transfer student. This is my second semester. And I was recommended you by I'm at prison program.
Oh, okay. Oh, thank you. Okay. So you okay, well. So you okay, great. And not all of you. I'm not trying to get personal in public. Like you any question I ask if you just want to put in the direct chat it's fine too, but it is good for me to know, so I appreciate it. So so this is your second semester you transferred. So but now you're a full
Yeah,
FOS John J. Awesome.
yeah.
Great. All right. And so dare I ask? And again, if you don't want to where did you take the physics one? You took it.
Yeah, so I graduated from Bronx Community College with my associates and I took it there. But I
Awesome.
didn't take part two because it wasn't a part of my curriculum, but it was like this whole mishap.
Oh,
So
got it.
today
Okay.
it's required, but for BCC's curriculum, they didn't have it, which leads me to taking it now in my second semester because I had to also finish my calculus too last semester.
Right. Okay. Thank you for okay. So welcome. I'm psyched you're here. Really, and all of you, especially all of you that there's a lot more than ever each semester. There's been a lot of shenanigans for a lot of registration, math requirements, transfer credits, e-permit, like so. And so some of you, now that Jay is reminding me, some of you, even if I'm saying I haven't met you, I may have already been part of a long email correspondence with some of you about the transferring of your math prerequisites and the this and the that. And let's just all have a fresh start today. I know all of that, and we're working on streamlining all of that. It's always changing and it's always annoying. But any of you who landed here, I'm glad you landed here, and it's my job to make you feel by the end that it was worth it that you landed here. So I'm glad. Okay, so that's Jay. Okay, I'm going to try to speed this. That's Jay. Then next, okay, another Denise. Denise, do I see Denise Chan? Do I see? Oh, maybe. So Denise not here. No, Denise. Okay, if anybody knows Denise, maybe let her know. I hope she got. Okay, all right. Noted. Um, Next, Gabriella Chiara. Okay, welcome. I mean, you're welcome to say some stuff about you if you want, but where I just lost you. Oh, there you are. Okay, but welcome back. Welcome back.
Thank you.
No problem. All right, excellent. All right, I'll do the welcome backs faster. But no, it's great to see you guys, really. And same thing. Okay, I'm going to try to go fast. I'm going back and forth between a million screens, and I don't want to take all day with this. And I really do know it takes me too long to get to things. I recognize that from that. So forget. So Genesis, hello, welcome back. I see you. I mean, I see your. Good to see. Oh, there she. All right, excellent. Welcome back. Awesome. Okay, thank you. Now Brianna with an E. Brianna G, in other words, I know I heard from you a second ago. Welcome. Do you just want a quick, we could just do this fast. I don't want to put every single person on the spot. I'm just acknowledging, um, I'll tell you this. How about this? If you don't want to say, I'd love to know anybody who I don't know if they didn't have Professor Talley, if you're coming from not Professor Talley, maybe if you could make that clear, either in the direct chat or with voice. Otherwise, I'll just assume that you're coming from Professor Talley, which is great. So welcome, Brianna, if that's the case. And I'll go back to the chat. Wait, where's the chat? Okay. Okay. I'm looking. Okay, so there's got to be a way to speed this up. Okay, same thing. Angelina, I think it did not. This is where also I'm. Oh, and thank you. Got director. Okay, Angelina, same thing, Professor Talley. Hello.
Yeah, I had you last
Oh my
semester,
God, that's what
so
I thought. Wait, sorry. Yes, I actually, right as I was saying that, I was embarrassing myself. I'm sorry. Yes, good to
no,
see
no,
you.
it's okay, it's okay.
No, it's not. It's terrible. All right, so now I'm going to really get to know you in person. All right, awesome. Thank you for coming back. Thank you for daring a second time. Okay. And I did know that right as I was saying. All right, this is see it all gets bad. Um, but if we didn't do something like this on Zoom, it'd just be death to be on Zoom for 2 hours or two. Like, all right, Chanel Jackson, same thing, I think. Welcome back. Um, I'm just gonna say, yeah, I'll leave it at that. That's Chanel. Camilla, welcome Also, wait, do I see Camilla? Yeah. Oh, thank you for showing the avatar. Also, that you'll see all in a second. Anybody like Chris, Camilla, Judith, all the Angel, people that are showing anything other than a black box, even if they're not showing video, they're getting points for that. You'll see in a minute. And the points are more clear this semester, I think, I hope. So thank you guys for doing that. So that's Camilla. Okay. Jibo, welcome back. I saw you somewhere. I know you're here. I think. Yes, Zebo, welcome back. I see you. Okay. Angel, also welcome back. I see. Thank you for showing the avatar. Jacqueline. Is Jack again, I'm trying to just cross-reference the official attendance here today. Jacqueline, you're here, right? I saw you. Yes. Oh,
You
yeah.
can call me Jackie. It's my preference too.
Okay, Jackie, thank you. And that also counts as respectfully correcting the professor, which you get points for. You'll see there's a portal for that. Thank you. And Jackie, did you have Professor Tally?
Yes, I did.
Awesome. All right, thank you. Great. And you just used your voice, which is also points. You'll all see those are. All right, now we're back to Veronica. Veronica, welcome. You also had Professor Tally or Yeah. Okay. Great, 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 great. All right. Then Gabriella M, welcome back. I saw you somewhere. I see you. I see you. Welcome back. Awesome. Thank you for taking the um being a repeater offender. Okay. And Chris, same thing. I see you. Welcome back. You're allowed to say, those of you, I'm not trying to blow you off. If you want to say something, you're welcome. I'm just trying to move it along so you don't have to say something. Justin Poon. Oh, there you are.
Hello.
Thank you. Thank you for showing video. Awesome. You just got points for that. Welcome. Awesome. And you were in Professor Tally as well?
Yep. I also had Professor Brunson, and I was there for the meeting that you did with him.
Oh, right. Wait, oh, yeah, yeah, yeah. But, oh, we didn't talk about that. Right. Okay. Yes, I knew oh, okay, that's why I recognize. So that's why I'm getting confused about some of the names. Yes, yes, yes. Thank you. Awesome. I remember that's great. And in fact, let's pause on that for a moment too. You guys in this section, I believe you have Professor Wu for lab this semester or Professor. Yes. Oh, thank you. Oh, thank you, Angel. Okay. Professor Wu. And that is on Wednesdays, of course. Right, right, right. Got it. Excellent. Okay. Professor Wu has been with us for a long time, by the way, folks. He left for a long time and came back, but he's been doing this for a long time. It's just to say, which is good to know. And I've got stories about him when we get anyway. Jocelyn, welcome back. Good to see you. And thank you for the video. And I like I'm not gonna okay. I like the evolution, the transformation. I'm just allowed to say that. George, also welcome back. Welcome back. Yeah, I see you. Okay. Welcome back, George. Oh, oh, thank you. Oh, I just got okay. Thank you, direct chat person. Nice to see you too. I'm gonna leave it at that. Okay, pause to say, those of you who don't know me, I take the chat very seriously. I try to take the chat very seriously. I take the direct chat very seriously. I'd like to keep it open all the time. I like to try. Sometimes I get in my head, but I like to look for it whenever I can. I encourage you to use the direct chat. I think it's one of the tools that we get from the Zoom age that we cannot do in a regular classroom. Oh, well, mostly you won't be on Zoom. That's right. I'll keep it. But whenever there's a direct chat, I will try to acknowledge, but I won't use the person's name. That's the bottom line with that. But we won't be on Zoom that much. I keep forgetting that. Lillian, welcome. Do I saw Lillian? Did I see Lillian? Is Lillian here? Wait. Lillian. Oh, yes. Thank you. Oh, and chat. Thank you. Awesome. Good morning. And also Professor Towley. Well, yes. Awesome. Awesome. Okay. Going back to, we're almost there. I know this is taking too long. Judith, welcome back. I saw you and I see you. Welcome back and I see you. Or I saw you. Teresa Schmidt, welcome back. I see you. I saw you. Wait, did I see you? Oh, yes, I do. I do. Okay. Brianna S, who actually did I have last semester? Now I'm getting all the Briannas. There's a lot of, I mean, there's a lot of Yaverbowns. I'll leave it at that. Brianna, I see you. Okay, I see you. Welcome. Um, Sue, awesome. Professor great. I see you. Thank you for the, got it. Awesome. Okay, I think that's, I appreciate that. Okay. That means everybody's here except for one person. I'm now going to quickly say, so we can start moving along. Since most of you, I'll just acknowledge, if I say your name now, it means you did put your, it means that you signed up with the Google Classroom, which is very important. To make it clear, just like with Professor Talley, from here on in, it's all about Google Classroom, right? I think that's clear to all of you. I mean, you found the Zoom address. I don't use Brightspace. I mean, from here on in, it's all grades, work, everything, Google Class, announcements, all Google Classroom. So you have to be in the Google Classroom to get a grade and to get credit for your work on all that. So I'm just gonna, if you hear your name now from me, it means good, we're solid, we're on the same page of Google Classroom. If you don't hear your name, please private chat me or something to make sure straighten up. But I think it is all of you. I think you all did it. But I'm just, so I've got George, sorry, I've got George, Aravello, Alex, good. J, Gabriella C, Genesis, Brianna G, Angelina, who I did have last semester, right? Chanel, Camilla, Zebo, Angel, Jackie, I think you told me to say, I think I'm getting used to it. Veronica, Gabriella M, Christopher P, Justin, Jocelyn, Lillian, Judith, Teresa S, Brianna S, Sue, Rebecca. If I said your name, we're totally good, and thank you for using your full name in your Google Classroom and all that. So if I didn't say your name, you want to private chat me or something. Okay, so we've done that. So we're all here. That's terrific. Okay. So now we can move on a little bit. All right, how to connect with me? Maybe same deal as that. So where I live is, I mean, where I live is far away, but my office is on the fourth floor of the new building, 04.61.05. It's so easy to find that it's impossible to find, meaning it's on the fourth floor, but it's not in the back hallways with all the other labs or all the other offices. It's just right there near the window to the jaywalk. Like you come out of the elevators on the south side, the men's bathroom side, you come out of the elevators, you turn right, start walking toward the jaywalk. And right before the window of the jaywalk, there's a door that you would never know is there unless you're one of the people that happens to sleep on the benches right outside that door or eat or whatever. There's a door right there. That's my door. It has my name on it. That's where you visit me, please. I encourage community hours on Mondays, i.e. right after this class. You could just walk when this class is over on Mondays. I'll just walk over there. You can walk with me. And I'll stay past community hour usually, but at least for community hour. I mean, it's also good to send, maybe tell me that you're coming or whatever. But occasionally I have doctor's appointments, but so that's official office hours is right after this class on Mondays. You can also always make an appointment for Zoom or phone call appointment for any other time. My cell number is at the bottom. Many of you know I do. Just use it appropriately, and introduce yourself the first time you send me a text, and then keep texts appropriate and reasonable. I can be more specific about that if I think you ever violated it, but I definitely do phone appointment. I travel a lot. I'm in the car a lot, so I'm happy to talk on the phone if my office hours are not convenient for you. Okay, so that's how to reach me. Now, here's a piece of unusual information I did not give you last semester. I mean, no matter whether I'm going to tell you right now because I think some things were less clear than I want to make things more clear this semester. So this is not in Google Classroom yet. There's an announcement that I've ready to post, but I haven't posted yet. Unless or until we find out of a conflict with Orgo, or unless or until we change our mind and announce it. I'm telling you right now, you can mark down the midterm exam will be, it's not 9:25. It would, in your case, it would be 10. Uh, and then this, hold on. Sorry, that's from the last class. Your midterm exam will be Monday, March 16th, 10:50 a.m. If it's a take-home exam, that means it's due then. Uh, and we did all take-home things last semester. There's a slight possibility that will change this semester. I will let you know if it does. If we do anything in person, that's when we would do it. If there's any component that's in person, it would be then 10:50 a.m. In other words, beginning of this class, Monday, March 16th. So my point is you can mark your calendars that our midterm is March 16th. And then the final, hold on, for your class, the final, bear with me for a second. I want to get this right. Yeah, the final, right. So the final is 12:30 p.m. Monday, May 18th. That's just that's literally when that's in accordance with the official John Jay final exam schedule. So it doesn't conflict, based on when this class period is. So it doesn't conflict with your other finals. So that's official, and that won't change. If it's take home, then that's when the final will be due. But if we come in and sit for anything, that's when we would come in and sit for it. I will get back to you about that. Again, that's maybe a slightly shocking thing to hear. I've been doing things take home forever since COVID, but at some point that has to change. And it might be changing this semester. Again, I'll let you know. I'm not trying to mess with you, but these are the dates to know until or unless we all realize that we have to change one of them. Unless we have to change the midterm. The midterm is March 16th. The final is May 18th. Okay, wait, I'm gonna look. Okay, yeah, I see the private chat. Okay, yeah, got it. That confused me too, actually. Okay, so maybe my handwriting is not great. Hold on, I'll make this clear. Okay. Again, if you had me before for 203, or even if you had Tally, most things are not going to radically change from last semester to this semester. But there are aspects that I want to just make clearer and better. I mean, I want to learn as I go, just like you. So yeah, some things will hopefully just be clearer and more streamlined this semester. So that's one of them that you should know that in advance. Now, as long as I'm talking about that, yeah, as long as I'm talking about that, again, the goal of today is for me to start you off and get you ready to turn in homework. Let me say right now, something that bothered me about last semester bothered me for you, not from you, is my grading system is my grading system is a little bit complicated and a little bit unusual, and it's meant to be very supportive. It's designed so that there's more than one way to get an A or more than one way to get a very high grade. Like that there's ways to get a high grade besides just only being really good at taking exams. That's the idea. But that does make it just complicated enough that it's a little bit hard to get used to. And it has a disadvantage that I haven't yet figured out a way to program Google Classroom so that at any given moment you have as clear an idea of your grade as you should and as you deserve. So I think I have streamlined things a bit or simplified things a bit so that I'm going to tell you right now. And this is what I'm about to tell you is in the syllabus. I added a paragraph in the syllabus to try to make this clear. So you can look this up later or you can watch this recording later. But especially if you've never met me before, like listen to what I'm about. Well, either way, hopefully this will make it clear to you, like how to track your grade as you're going. essentially, even though Google Classroom will not. Google Classroom will not tell you a clear picture of your grade snapshot. It will tell you all the grades that you've gotten, but it won't put them together for you in a way that will help you. So please hear this. This is the idea. In Physics 204, your lab is worth 33% of your base grade. That's a slightly different percentage than 203, and it's a much more convenient percentage for this reason. At the end of the day, at the end of the semester, you will have your midterm grade, you'll have your final exam grade, and you'll have your lab grade. Each one of those is 33% of your base, like, exam grade. So point number one is you take the midterm, the final, and your final lab grade, and that you track your lab grade with your lab professor. But at the end of the semester, you would have a midterm, a final, and a lab grade. Those three would be averaged together of equal weight to make your base grade. Then anything and everything else that ever happens in lecture, any points that you ever get in lecture from regular homework, like that we're going to get to today, you're going to see regular homework sheets, or all these participation points that I keep referring to that I'm going to show you in a second, any points that you ever get for anything else in lecture besides those exams, okay? Any other point values you ever see, the rule of thumb is just to divide those points by 50. That's conservative. You'll see in a second, the homework that's due this Monday, the physics homework that's due this Monday that we're going to start talking about, you'll see in a second that's 50. It says 50 points on it. What that means is 50 homework points. What does that really mean? It means divide that number by 50. It means once you get a full score on that homework, once you get all the 50 points on that homework, that amounts to literally one more point on your final average for the whole semester. It literally means if it's a 50-point homework, it means divided by 50, that equals 1. It means if you got the full credit on that homework, whatever your exam average is at the end of the semester with your labs, you would add 1 point to that from that one homework that we did. If we have another homework that's bigger, that's 100 points, you divide by 50 still, it would be equal to 2 more points on your average. So this was also true last semester, just I didn't have a clean, easy number. I just didn't have it. I wasn't expressing it as cleanly as this. I didn't have a rule of thumb number that I should have had to just say this to you. The truth of the matter is that 50 number that I just said, like, use that. The fact is that number changes from semester to semester based on everybody's grades. I can explain that later if you want, but it doesn't change from student to student. It's always the same number for all students, the dividing number. And I'm telling you right now, I'm basically making you a promise that even if I end up dividing all your homework points by less than that, I won't divide it by more than that. In other words, that's conservative. This is the lowest your grade could be. You will be at worst underestimating your grade. If you see what I mean. So I am saying at any given moment, if you want to know your grade in this class, at any given moment, take whatever you're doing in lab, take your midterm exam once you have it, average them together. Until you have a midterm exam, just take whatever you're doing in lab, okay? And add up all of your homework points, all of anything you're doing in lecture with me, add them all up, divide by 50, and add that to whatever's happening in lab and whatever's happening with your exam. And that's a conservative projection of what your final grade is looking like at that moment. Just always divide by 50 is what I'm saying to you. I did not say, okay, does that, so divide anything that isn't an exam score by 50. Again, you're going to see this more clearly when we start. I see the question. I'll answer that question in a second. Okay, so the grading system isn't as complicated as it sounds. If you so in a minute, we're going to do an exercise together that's worth 5 points. That really means we're going to do it together in this room together. You're going to get the points. You're going to get 5 points in this room in like 5 minutes. What I'm telling you is in your mind, what does that 5 points mean? Where does it go? It really means that's point 1 added to your final average at the end of the semester. And okay, wait, I'm gonna pause. Oh, and there's a question in the chat. Is it still group labs? Yes, it is. For good or for bad. The whole way lab works is still the same as last semester. I mean, I assume that last semester, yeah, you did the whole thing with the yes, it is still group labs. I don't want to get all rabbit holey or defensive about that because I know people hate that. I know you hate that. I know people hate a lot of it, but it is what it is. I don't know that you particularly who are asking the question hate that, but a lot of people hate that. But my understanding too is just to be clear, yeah, you all get one grade on each group lab report for reasons. But then if I understand correctly, and we're still doing it the way we always have, when you take that lab quiz, you take that individually, and then that is supposed to end up being a multiplier on your grade on your lab report. So tell me if I'm wrong in the private chat if you want, but my belief is that, yeah, you all get a group grade on a report, but then the individual grades that get recorded in the book ultimately are differentiated uh, by how you do on the quiz, and that's on purpose. And that's why the quizzes are really supposed. Well, anyway, so I think that's the idea. You can tell me if I'm wrong, but I'm going to pause for a second. Again, we're going to look at particular. Look. If you're in this room now, that means you got through last semester. Great, I'm thrilled. Maybe you didn't get the grade you wanted, and if you still have issues, we can talk about that privately. But in many of your cases, hopefully, especially those of you who did have me, hopefully those of you who had me can privately report to the people that didn't have me. I would like to believe that even if not everybody's grade was what they wanted or hoped for, or I would believe that in many, many cases, the students will report that the grade they ended up getting was higher, noticeably higher than how they did on their exams. And that's as it should be, because that's not the only work you do in this class. So everything I'm saying right now is meant to show that your grade comes from something other, not just exams. And oh, last thing on that, and we'll move on. All of this other stuff, all of the homework, all of the participation, all of those points that get added to your average, they do just get added, and they're not percentages. They're just extra points. In other words, if you fail to do a homework or you fail to do a participation thing, it's not a zero, it's not a penalty, it's all just extra bonus that you can accumulate. And if a homework is worth 50 points, but you only get 40, you're not getting a B on the homework. You're not getting percentage. You're just getting 40 points divided by 50 rather than 50. You're just getting 0.8 added to your average. I mean, you're just getting 0.8 points added to your average rather than one. It's all extra. There's no penalties for any of that stuff. I'm going to pause for a second, especially for those of you who don't know me. Bottom line, I'm saying, what's your grade at any moment in this class? Google Classroom will not tell you. To know your grade in the class, look at your lab average it with your midterm once you get it, and add all of the points you've ever gotten from me, but divide them by 50. I'm going to pause for a second. Can you give me like electronic hand or something if that basically makes sense? Thank you. Thank you, Gabrielle. Thank you. Awesome. Thank you, Dennis. And some people who I didn't have before. Great. Okay. It looks like a mix of people I've had before and haven't. All right. Cool. And it doesn't mean you can't ask me again in private, but hopefully that's all right. And hopefully that's a little simpler or to keep in your mind than anything I didn't say last semester. Okay. And again, the 50 is conservative. Your grade might even be better at the end, but it won't be worse. Okay. Okay. So that's that. Therefore we can start getting into stuff. How do we get on all that? Oh, because of the exams. Okay. Oh, all right. So we're almost up to this. So now what we're going to do, thank you, Judith. Awesome. So now what we're going to do on that note for everybody, I'm going to switch the screen share. 1 second. Um, okay. So this is what the Google Classroom looks like. I believe you're all in it. That's good. Of course, it looks slightly different on my side, but only slightly. Okay, this is where we live from now on. Um, you know how streams work. If you've never used Google Classroom, I mean, most of you have used it, whether it was Professor Tally or me or high school. But if you've never used it, you can reach out to me. I'm never going to say anything is easy, but it is Google. This is not a paid advertisement. Most of you know how to, anyway, if you have any problems, reach out to me, but I think it's fairly straightforward. All right. So this is the Zoom link where I live from that. You found that. Hopefully we will use it from time to time, but mostly we won't. This is right here is the YouTube channel where I should say, anything I'm taking notes right now, I've been taking notes on the board. That will become a PDF that gets released to all uploaded to this. I'm going out of order. Sorry, let me back up. This will be recorded, what we're doing now, for good or for bad. It gets recorded and it gets uploaded to the channel. So if you miss something or it goes too fast or before an exam, you can replay the class. You can also, you can also replay all classes from all past versions of this course. They're all in playlists. Every single time I've taught Physics 204 since COVID, it's all in a playlist. So if I'm ever explaining something that you really need to know and you're waiting for that moment, like, okay, now he's going to explain what omega is, and then you don't like my explanation or somehow I blow past, you can find another version of the explanation in some past semester. So I encourage you to do so. So it's all here at the YouTube channel. Okay. Class notes. Everything we're writing down right now, I'll upload as a PDF. It'll go right here after the class, class notes number 1, number 2, number 3, etc. Stop me if I'm going too fast. I'm just trying to. Now, we're going to get this homework right here, homework 1A thing on a spring. This right here, due February 2nd, 10:50 a.m. That's what's going to be due in a week. That's what soon I'm going to start going over with you today. I'm going to start doing it with you for you today so you'll know what to do. And yeah, and you'll notice it's worth 50 points. So what does that really mean? It really means it's due a point on your final average, which is not small, right? Considering this is just one homework. If you get all the points on this, that means your average goes up by a point by the end. I hope that's increasingly clear. We're going to start talking about this in like 15 minutes, but before we get so that's like regular physics homework. Before we get to that, you'll notice that there's all these other homeworks under section 0 called game, points, and participation. That's a part that I'm sure is boring to tears. Many of you who know me already, like that's a thing from last semester. But those of you who don't know me, that's kind of a weird, unusual thing that requires a little bit of explanation. And I have to keep remembering, and of course, and it applies to your class this semester, even though thankfully we will mostly be in person. So some of these portals that exist here are not as relevant. Like some of it is designed to encourage more participation in Zoom, but it still applies. All of this still applies even when we're in person. For example, game turn 1 that is due tonight at 11:59. Every time we have a class is like today's class 1, so it's turn 1 in the game. It means you have till tonight to send me what it says here. Here, I'm going to open. Wait. You have till tonight to send me a very quick, super quick, like 1-sentence reflection or screenshot on some way that you participated today. It could be as simple as, so what you're going to do, and by the way, we're going to do this right now. All of us are going to do this right now. You're going to show me that right now you can submit something through Google Classroom to me, and I'm going to show you right now that you can get 5 points right now. We're going to have that transaction. So if nothing else happens this entire double period, we can both go away with one successful academic transaction in our books and know that we know how to proceed from here. So this will happen every day, every class, well, every week. By midnight tonight, you're going to go to this portal. On your side, I think you see a plus sign or something like that. It says like create new document. You're not just going to write in here. You're not just going to write down here where it says class comments or something, or even private comment. You're going to open up a new document, like create new Google Doc or whatever, or add it or attach a new document. And you're going to write one sentence, such as today in class, I said hello. Or today in Zoom class, I showed video. Or today in class, I raised my hand and I offered that, and I said that it seemed that Yaverbaum was missing a minus sign on the whiteboard. Like anything that you did, or even, and this really is important for some of you, or even today in class, I took intense notes. I even wrote down things that Yaverbaum didn't put on the board. Here's a screenshot. I mean, here's like a picture of my notes, and you upload. In other words, it doesn't even have to be that you were talking. Like some people like to talk more than others, but some way that you actively engaged in the class. You're going to take one sentence and put in like one screenshot or something if applicable, and you're going to say that today this is what I did. You're going to upload it here in this portal. It's going to be a separate document for sure. Like it's not just going to be written in the comments here. You're going to upload it by midnight of that night. As long as you upload it by midnight of that night, you'll get it back from me. You'll get 5 points. On that quick thing, you might often not even get comments. You might just get the 5 points, just as long as I see that you did it. But it's just a quick weekly reflection, like that you somehow engaged in the class. And you'll get 5 points back. And I'm going to ask you right now to do it right now, all of you. You're just going to send it to me. Other people won't see it. But what we will see okay. So for example, 3 people have already turned it in. Thank God. Thank you. There's 19 left. I'm going to turn off the screen share in a minute. And we're going to pause right now. You're all going to just do it. If you haven't said anything in the class yet or done anything, but that even includes showing an avatar in your square or anything like that. If you haven't said anything, just write hello in the private chat if you want. Just introduce yourself in the private chat and that will count. Just do something and then send in a little document right now. And as long as you do it correctly, you're going to right now, we're going to take 5 minutes to do this. You're going to get a comment from me this time in the document to confirm that we're on the same page. And you're going to get 5 points from me right now. Again, remember, what does that 5 points really mean? It really means 0.1 on your final average. But I'm saying this will happen every single week. So it adds up. If you don't do this by midnight, you just don't get the points. There's no penalty or anything like that. You just don't get the points. But you do have to do it by the midnight. The portal will shut down after midnight tonight. It's like pointless to do it later. It's impossible to do it later. So, okay, 11 people have already turned in. That's great. So I'm going to shut up. I'm going to say one more thing, though. Right now in this exercise, when you're going to give me a minute, like I'm going to go through them very quickly. I'm going to give them back to you very quickly. You should confirm that not only you see 5 points on your side, but also I'm going to ask all of you, because this was an issue last semester. Make sure that at least right now that you get back something that literally has a comment in the document. Like you'll in a minute see a highlight, like you'll see a yellow highlight, but that means that I wrote something in the margin of the Google Doc or whatever of the thing. And it will be very fast, like thank you, welcome or something. But make sure you can see that comment, because this is the way that we are going to interact and communicate through your proper physics homeworks and probably your exams. So if you just see a yellow highlight, but you don't see a comment, we want to pause on that and make sure that gets addressed today, right now, because there should be a comment there in a minute. So I'm going to shut up. I'm going to take this down. So you don't see me doing. I'm going to take this off the screen, but bear with me. Thank you. 17 have already done it. 5. So I'm going to very quickly now just go through, and you should all get points right now. Oh, and I'm sorry, Jay. Yes, Jay, you have a question.
So, this game thing, it has to be done after every lecture, or is it after every lecture and lab?
Oh, great question. Great question. This is a total lecture thing. Yeah, whatever happens in lab stays in lab. Like lab is like yeah, lab they might do things like this, but they generally don't. And yeah, whatever they say in lab is what you do. And if you ever have a conflict, you come to me. But no, this is not about lab, right? This is just about me. Um,
Also,
so
have you as a lab professor.
say again, I'm sorry. What?
They don't have you as a lab instructor as well. Like I think it's kind of different because I've only taken one science course. I took quantitative analysis, and I realized John Jay does things different. Like there's two separate professors.
Oh, yes, yes, yes. Okay, so let me pause on that. Sorry, that's a great question. Wait, I'm going to stop this share for a second. Keep doing what you're. Um, that's a great question. Okay, so anybody who is new to this, so yes, your lab on Wednesdays is with a different professor. It's with Professor Wu, I believe someone confirmed. Yeah, it's a different professor, and you'll see my name, and he'll have a different Google Classroom. If it's not already set up, it will be. He'll have a different Google Classroom for lab. You'll see my name in it, like every single thing he posts in Google Classroom, and I will see, and also his name will be on mine. So we're trying to keep in communication at all times. Wait, let me pause for a second. Is it Professor Wu that you have? Is that correct?
Yes.
Okay, great. So you should also know, like, we've been working together for a super long time. He knows, once upon a time, a long time ago, he was a student in this. Like, he knows the lab inside out. We've known each other for a long time. We meet every week, so we're in constant communication. He'll know what's going on with me. I know what's going on with him, with you. Blah blah. But it is a different professor. And yeah, to be clear to everybody, especially like e-permits and all. He does all the grading. All the grading happens over there, and he's the boss over there. Um, and then at the end of everything, all your grades to him all come together to make one final lab grade. But then that final lab grade is sent to me in the last week of semester for each one of you. And that final lab grade gets incorporated into our grade, like it's 33% of the base grade. It gets incorporated in here, and then you get one final grade for the whole package from me. But all the individual moments are coming from him.
Mhm.
Right. Okay. So what that really means to all of you, that's a really important thing. Um, I mean, he's the boss of lab, and what he says goes. But if ever, and really, we have a long-standing working relate. Like there should never be a conflict. I don't think you'll feel a conflict. I think you'll feel that it's all in harmony and it's all related. And often he'll even come to me and say, "Oh, we didn't get to this. So can you re-explain this in lecture you have about?" Or he'll say, "Wait, are you falling behind lecture? I'm supposed to do this lab next week, but are they ready for?" Like we'll try to keeping it coordinated. But if ever you really do have a conflict, like somehow, like he gives you a grade and then like you know, not comfortable with the grade, and then but then he won't, then yeah, then eventually come to me because in the final analysis, the grade does come. It all goes through me in the final analysis. So if you ever really have an issue, let me know. But that's okay. That's how it works. Did that answer the question,
Yes,
Jay? Okay. All right. Thank you. Okay. So, okay. Now, so back to what we're doing right now. So someone's asking directly, how do you submit? So for this game assignment that we're doing right now, game term one, let me just see, because someone's asking a question, but let me see if they already figured it out. Maybe. Hold on. Hold on. Oh, I think that person already figured it out. It looks like, right. So yeah, so great. I'm going to pause for a second. I'm going to go through these right now just to make sure that we're all on the same page. And in a minute, what you should get back from me, you should see a yellow highlight and you should see some little comment to the right that says like, perfect, thank you. And then we know we're on this. If you don't see that comment, you're going to want to let me know in a minute, but give me a second. Hold on. Almost there. Sorry, bear with me. Okay, I think. Okay. Okay. Yes. Think. Oh, okay. I think. Oh, all right. You should get it once. Da, 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 da. Okay. It's happening now. You should get the five. You should see the 5 points, and you should let me know if you don't in a moment. And you should see some kind of comment, to the right margin. It's kind of important. Like this comment doesn't mean so much, but it's important that the system works. So see if you can see like a thank you, welcome, or something comment to the right. If you don't see the comment, I mean, they're still coming as I'm saying this, but if you don't see the comment to the right, my advice is that first open a new tab. Wait, there's one person that didn't get it. 1 second. Sorry. One person did not. I know who you are. Hold on.
For mine, it said that I had to like reload the screen. So it showed I got an email that you viewed it and that you graded it, but it didn't show immediately until I refreshed the document.
Oh, okay. Okay, good to know. But then when you did refresh it, then it did work.
Yep, correct. It shows me the comment on the side, and then on the homework itself, it shows a grade. It says 5 out of 5.
Great. Okay. So good. So there you, so yeah, refreshing is sometimes really necessary and helpful. And the other thing is that even if refreshing doesn't work for some of you, and again, I'm saying all this because this became an issue in exams for people, like it slowed people down in exams last semester from this not to be clear. Um, at worst, if you see a highlight, that means there's got to be a comment somewhere. So even if refreshing doesn't work, then sometimes people, if you literally go and open your Google Drive directly, which you automatically now have one if you have Google Classroom, I believe. Like if you open Google Drive automatically and find the document in there, then you'll see the comments there. I mean, that's annoying, but at worst, do that. Okay. Huh. What we do? Um, we okay. There's a question. So okay, there's a question in the chat. We'll be doing string theory this semester. We're not going to get quite to string theory this semester, but we are going to get far to some cool places, hopefully, and hopefully move. We're going to get to farther things and deeper things than we did last semester for a variety of reasons. So, but maybe not quite string theory, but but I'm going to take that as a challenge. I know that was kind of a joke, and it is funny, but I'm going to take that as a challenge. That there are certain places in this course where I will hopefully be able to mention to you, show you like why, how aspects of this course relate to sort of why people do take string theory seriously. I'll try to remember that. I know who you are, who just asked that. A quick thing about that too. Well, again, it's not so relevant because we won't mostly be on Zoom, but you notice if someone puts something in a direct chat, I will not out the person's identity. But if it's helpful and related, if the concept, I may refer to the concept. But okay. So hopefully you all, yes, you all got 5 points, which really means 0.1. So you all just got 0.1 on your grade. Is that's clear to everybody? Okay. Now we can start getting to so every week just do that. If you don't do it, nothing happens. But if you do it, you get that's 0.1 more on your grade. Now it gets a little bit more specific. Let me go back to the Google Classroom again. Oh, I just lost it. Sorry. Okay, yeah, going back to the Google Classroom. Right. Okay. So that was turn one, right? That was this. You just did this right here. So you just knocked off your homework for tonight. And then next week there'll be turn two, etc. But then after that, you notice there's all of these portals here that are all due May 18th. So what's that about? Again, they're all optional. If you don't do any of them, nothing bad happens. But all of these are all of the other ways that you could participate. There are specific ways that you could participate at any given moment, some of which are specific to Zoom, but many of which are not. And so, for example, this and some of the titles are overly cutesy. Like sometimes you have to like open it to understand what the title means and then read the actual instructions. But here, for example, this one that's speak now or forever hold your something. This is anytime you use your voice. Now that definitely applies to in-person class. Anytime someone uses their voice, anytime you use your voice, you can submit into this portal anytime. And it doesn't have to be proof. You could just write out on the document, like today, when you said sign of 0 is 1, I shouted out, no, sign of 0 is 0, or like whatever. If you said something, you just remind me here in this portal that you said something. You don't have to prove it. Once you remind me, I'll remember and believe you. You put it here and and you'll get it back. And that's 20 points, which really means 0.4 of a percentage point, right? You could do this every single day. of every single week. You could do like, and the reason it's due May 18th, it means you can use it anytime throughout the semester and you can use it multiple times. So there's a many portals like this. Anytime you should on your own time, like just check them out and look through them. There's many different ways to participate, including you could take a shot of your notes. If you take really good notes, you send it in, or if you help another person, that's called multiplayer co-op. Just so I'm not going to go through all of them right now, but you should be aware that and if you ever can think of a way that you participate in class that you don't think is recognized in any of these portals, literally send me an email saying, say, can you make a portal for really good eye contact or something? In fact, I think I have one, but like that's a thing. Some people in the middle of class, they don't like to talk, but they really make it clear to me that they understand what's going on while I'm talking. That's super helpful. So any way that you participate, there could be a portal for, and anytime you do it, you just use the portal, and you get those points anytime, multiple times through the semester, and you can double dip and so forth. So hopefully so all of those points are what I mean when I say they're all just always divide by 50, whatever it says here, divide by 50. And by the way, if you want to ask, why didn't I just make them what they are? I tried that in Google Classroom. Google Classroom will not accept point values that are non-integers. That's the only reason. If it did, I would have just changed all of them to make it that much more clear, but I just can't. Okay, so hopefully that's clear. So I'm going, are we clear? So, especially people that, yeah, okay. All right. Even that, that's an example right there. Not only did somebody just nod to say that I could go on, but in fact, you'll see, because you'll need this with me. Some of you know this already, that you need this with me. There's a portal that says, please, there's one portal that says, please go back. If I talk too fast or I write something and I move on too quickly I'm about to erase something or something in the real class, I mean, you can stop me and say, wait, hold on, I missed that. Can you please go back? That's a very important thing that for you to do. And if you have the guts to do it, I'm sure it's helping other people as well. So there's a portal that says, please go back. Say, today I asked you to repeat something that you erased from the board. So you get points for that. But similarly, like, not to single her out, but like Gabriella just did, there's a portal for please go forward, because you can see I rabbit hole if I'm not careful. So any way that you can make it clear, like move on, you get points for that. Okay, it's a million things like that. Check them out on your own. I'm moving on now. Okay, so therefore, okay, so that's all of that. Now, this finally brings us, it's 12 o'clock. Oh, it was almost perfect. This brings us to the real physics homework that also is always happening. That's all preparation for the exams and all of that. And the first of which is this. This is due next week. This is real physics now, okay? We are going to together start going over this. Like, I'm going to start doing it for you in a few minutes. But it's due next Monday. It's due a week from today. And that means it's due at 9, it's due at 10:50, when the class starts. So I want to start telling you what it means to do these kind of homeworks. One thing to say right away is you'll notice this homework is worth 50 points. So then I already said that. It's worth a full point on your average once you get all the credit on it. I'm going to switch. So we're going to go over this, but let me switch screens again. Sorry, to make some comments on what it means to do homework for me and therefore exams. What am I trying to do? So I'm switching this share again. No, sorry. Okay. Okay, so how to submit homework. I mean, the electronic procedure is the one that we just performed together, but now let's get a little bit more explicit when it comes to the actual substantive physics homework. So the first, and again, to some of you, this is redundant from last semester, but to some of you, it's not. First of all, you're going to take out a separate blank sheet of paper. Ideally, a real piece of paper and a real pencil or a tablet of some kind. And you're going to submit full solutions to our problems, not on the original sheet. You're going to act as though you're using an exam blue, an old-fashioned blue book. So on separate sheet, you're going to start writing out responses, solutions to the physics problem. And then you're going to scan in that sheet and upload it to the portal, now, ideally as a PDF. Let me pause on that for a second. With the quick little thing that we did a moment ago with the participation homeworks, it's perfectly fine. It's just like open a document right there, or even a Word doc, whatever people were doing is fine. But I want to make clear, especially after some exam experiences last semester, Google Docs work, but PDFs really are the best. And you'll find ultimately they're the easiest, generally speaking, for you also to send me PDFs. I mean, I'm talking about real physics homework now and exams. So and really what are the worst? I mean, I get them sometimes and they work, but they really cause problems is Word docs. I'm going to I got a couple a second ago with this little thing. That's fine, like the little participation homeworks, but with the real physics homework and exams where I need to put comments to the right and stuff, and I need to be able to specifically say, oh, this line is wrong or this line is wrong or whatever, really PDFs work the best. And really Word docs, they look like they go through, but they don't allow me to select one bit at a time, only one page at a time. That's very technical, but what I'm saying is, ideally, especially if you've never had me before, you write out the homework on separate pieces of paper. Then you take pictures of the different pages or you scan the different pages and then put them together as one PDF file. I mean, it could be a Google Doc, but really the safest, easiest thing is a PDF. And the safest, easiest way to make a PDF, it may sound like you need some fancy file converter thing, but no. If nothing else, you take a picture of each one of your pages that you did and then open up a Word doc. You can open up a fresh new Word doc. You insert a picture of each page that you did. You insert the picture on each separate page of the Word doc. So if you had 7 pages of your original, you took 7 pictures. Now you open up a Word doc. On page 1, you put picture 1. On page 2, you put picture 2, etc. And then you hit print. You go to print, but instead of printing to a printer, you print as PDF. And that will work. And it'll work beautifully. So not to drag this out, but honestly, I really want to get your exams back to you fast this semester. Is really what it, and I have less like drama about it. So not drama, there wasn't drama, but like less stress about it. I mean, both. So PDFs work a lot better. So you're going to write your homework out and then turn into one file, one PDF. If you do type out your homework on a computer, that's another thing we can talk about that. That gets into you. I'm not saying you can't do that, but even there, convert it to a PDF. Print it as you can always, even if you're doing a web browser thing, you can always hit print, right? You can always go to the print icon or whatever, and then there's always an option print as PDF. Most of you know, but maybe some of you don't. Okay, so you're going to turn in your document as a PDF for your homework. Now, and it's not going to include my questions or anything like that. It's just your solutions. Now, I'm about to get into more details of exactly how you do those solutions, and I'm about to show you an example. But I think since it's exactly 12:06, let's take a 10-minute break because this is long. I mean, technically the break would be at 12:05, right? Because then the class starts. So let's take a 10-minute break till 12:16. And then I'll continue with all of this. Okay, So yeah, let's take a break. Oh, cool. Thank you. And this, yes, everything I'm saying. Wait. I'm going to stop the. You can leave. Huh? Well, all right. Well, 12:07 is when because there's a good question. Yes, everything I'm saying applies to exams, assuming the exams are take home, which right now they are. Yes, and this is everything I'm saying is to prepare you for exams one way or the other. It's all practice for exams. So yes. And then a very simple free. So you guys in the chat you should submit. There's a multiplayer co-op portal like JDJ. You should find the multi and screenshot what you just wrote in the chat and put it into multiplayer because it helped the whole class that you just did that. Simple free app. Oh, Genius Scan. Yeah. Totally. All right. I'm gonna shut up. I'm pausing the recording. It's 12. Come back at 12:18. Okay. Okay. Sorry. I was muted, but I hadn't started. Or I hadn't started when I saw them. I'm starting now. I was muted. I was not speaking about the problem. I was getting myself together. Then I was muttering to myself. Thank you, direct chat person. Um, okay, wait. But yeah, I think this is where we left off, right? Okay. When the recording is going and you guys are back. Okay, terrific. So, um, yeah, so right, we're about to start doing that homework 1A. I'm trying to be as clear as possible about like how to turn in homework. To answer someone's question in the chat, yes, in principle, each homework is like practice on every level, on the physics level and on the sort of class expectation level for what to do in an exam. Now, there's a small possibility that some aspects of exams might be changed this semester to improve things. But nonetheless, yes, this is everything I'm saying in one way or another is applicable to exams. Yes. Um, so, so, so in part, I'm talking to people that have never met me before because how could you know what my expectations are? But to be honest, I'm also talking to people that got used to me last semester. Like, I think that for some of us, there still were things even by the time of the final exam that I could have improved my communication more. And in some cases, some of you like still were turning things in a way that made it harder for you to show your best work to me and have it be seen in the most efficient amount of time. So I'm sort of am talking to all of you, like fresh start for all of us kind of thing. Um, when you do homework, take out fresh pieces of paper, start writing on them. Don't copy and paste the original questions. Just make a new, fresh document that you're going to scan and turn into a PDF. Okay, we said that. And then specifically, it says here, make it this is the part that I think some people still needed work on by the end of last semester. You always want to give me a self-sufficient document. And yes, that definitely includes exams. The goal is self-sufficient document. The ultimate goal of why I'm going to emphasize this and explain it, the ultimate goal is you not only do you want to learn physics from this class for sure, like I want you to learn physics from this class, but we're also sort of trying to train ourselves to be able to publish things, to present scientific material in journals or at conferences or on posters, etc. We are trying to train ourselves, or even if we go into other areas, into crime, into forensics and stuff, whether it's the government or the police force or whatever, we are trying to train ourselves to be able to give documents to other people that produce constructive results, right? And we're in an increasingly document-oriented age. I mean, anything I'm saying here, it doesn't matter whether it's electronic or not, and it doesn't matter whether, or it does matter, whether AI is playing some role in all of this. It's all taking all of that into account. We really want to become the kind of people that can get a task done with a document, in with as little amount of work being imposed on the reader, the receiver of the document as possible. I'm just trying to say that this emphasis I'm about to make on self-sufficient document, it's not meant to be arbitrary. It is meant to make this physics class go smoother for you, but also so that this physics class has some value to you in later life. So what I mean by a self-sufficient document, an SDD, is, well, what it says here, what my handwriting says here is all questions and context are organically presented throughout the submission. A person who knows physics, or even is just an educated person, a person who knows physics but does not know this class, can follow. Okay, that's what it says. Let me put that. What I'm saying is you always want to present a document that does not require another document or another piece of context or an insider understanding to follow. You don't want to present insider communication, right? So you want to more and more look at my assignments or my exams as something that, yeah, they start off as an assignment or an exam. It starts off as something I'm throwing to you, but then how you want to catch it and send it back is you want to send it as a piece of work that could stand on its own merits, that could be sent to somebody else to either learn something from or help you. Like, you want to think of your homework that you do for me as something you could then turn. Either you could send it to a journal and say, look, this is an explanation of how masses on springs work. I bet you like, maybe it's not totally original or totally groundbreaking, but it's clear and it's correct and it's helpful. Maybe it's going to a physics education journal or something, whatever. Here is an explanation of how springs work. Or it can go to a tutor, right, in another institution or something, and say, here's what I'm trying to do. Can you help me with this? But you shouldn't have to waste your own time or the tutor's time or the publication's time. You shouldn't have to back all up and say, well, this is what Yaverbaum meant, and this is what he's asking, and here's the question, and here's how we do it in class. No, like, you want to present something that stands on its own, that anybody who has any kind of background in science or physics could read and follow and help you with or learn from, even if they weren't in the class. That's the goal. It's like, I know I'm dragging this out, but this is where I think we really can both help each other a lot. Like, even this was kind of needed help even up to the final exam of last semester. The standard is like HBO shows or Netflix shows or whatever, I mean, not to be silly, but the brilliance of a lot of these like or shows that now, I mean, whatever, like classic ones from when I was younger, like The Sopranos or 6 Feet Under or whatever, or The Wire. The brilliance of those, and now they're all kind of different. I know I'm dating myself, but like these kind of shows, the thing about them is, sure, we all appreciate them more. We all appreciate episode 4 more if we've already binged watched, episodes 1 through 3. Sure, you get a reward for tuning in episode, and following the characters and all that. However, all of those shows are brilliant enough that they design them so that anybody could just at any moment just tune into episode 7 and get hooked, right? Like, episode 7 of a good show stands on its own and makes some sense, even if it has a thing at the beginning that's like, what happened on the last episode, blah, blah, blah. They do it in a way that you could take that package and you now get it. You feel like you know what's going on. You appreciate it enough. You're not confused that then you want to go back and watch episodes 1 through 6 and continue with episodes 9. You get my point, right? So that's what you want to do with a document. The document should stand on its own. So that means, at a bare minimum, you don't include my questions, but you're going to make in your words clear like what my questions are asking, and then you're going to thoroughly respond to them. Okay, I'm dragging this out, but again, I think this was something that's the standard. You think of my homework as not only practice for my exams, but think of it as practice for you creating a document of good physics work that could go somewhere else. So that's what I mean by self-sufficient document. Okay, bottom line too, to make this more concrete, and then I'll move on. The flip side, the more concrete side of this, the more practical side is, what I'm also saying is you want to give me something that I can grade or I can mark, I can help you with, give feedback as quickly as possible without me having to refer to other documents to do it. Like I haven't memorized every single detail that I've said in every single homework assignment I've made. I mean, I kind of have at this point, but like you want to give me something that I don't have to cross-reference anything and I could just look at what you're doing and be like, yeah, that's right. That makes sense. Oh, no, that doesn't make sense. Oh, that makes sense. That makes sense. Your standard is, can Yaverbaum read this and follow this and give me feedback or give me a good grade or whatever, record a good grade without him having to look at anything else in order to follow. That's the standard. So that's what I mean by a self-sufficient document. If I ever write SSD quickly on something on a homework or something, please, at least, even if it's still not clear to you, please refer back to this lecture or this PDF and look it up or ask me privately. But that's what I mean by self-sufficient document. Okay. And then the next thing. Oh, sorry. Funny. I see in the chat. Oh, wait, sorry. Oh, no. Wait. Sorry. Two good questions in the direct chat. Okay, one question in the direct chat is, oh my God, right. It's been so long since we've had in person. I didn't even. No, correct. Someone's asking, do I want physical homework copies or just PDFs? I don't want physical copies. I'm past that. I apologize if that's a problem for you, but no, I mean, I'm talking about homeworks now. Exams, if the exam is in person, then that's one thing, but we have to deal with that a little bit later. But no, all these homeworks and stuff, even if we're meeting in person, I mean, even though we're meeting in person, I still want all of this stuff electronic. I mean, I can't carry the paper. I will lose you don't want the papers in my possession. They will, and especially the person who's asking this question, I know how much he or she takes care of his or her work. You don't want to trust me with your physical work. It'll not come back to you in the condition that it deserves. Like I know the person asking me this is more organized than I am. And I mean that as a compliment, obviously. So no, yeah, it has to be all electronic. It has to be all electronic. I apologize if that's a problem. You can talk to me privately if it's a problem. But right, even though we're meeting in person, all of our document exchange is electronic. Yes. Okay, hopefully that's clear. Let me know if it's not clear. But now also someone else is asking in the direct chat, do I still want the 5-step method format for solutions? Funny you should ask. Yes, I do. That's the next, as you can see, that's the next thing I'm about to get to, is that yes, I have a particular format of how I want these solutions presented, whether it's in the homeworks or the exams. As you noticed last semester, some multiple choicey things might sneak up on you now more, and it won't be a surprise if they do. There might be more of a multiple choice element to exams or things as we go, partly so that we don't get into the exam grading rabbit hole that I got last semester. But barring any multiple choice things that might come up, yes, I still want the homework according to the 5-step method format. So I'm about to explain that to people that don't know it. People that do know it, I know you hate it. Many of you, I understand that. I'm not doing it to torture you. I know. I promise you that more and more after people get through these two classes and get into PChem and instrumental, they do tend to come back and say that they really appreciated the torture of it, just not when it was happening. I mean, I understand you don't like it, but yes, I there's 1,000 reasons I think it's good for us all. So now I'm gonna direct your attention to the 5-step method. So my two things I'm saying to everybody, I want the homework and exams to be self-sufficient documents. And yes, I want them presented according to the 5-step method, which I'm now about to show to everybody or remind certain people. Yeah, okay, I'll pause on that for a second. So quick screen share, I'll show you. In terms of the 5-step method, you will see, whoop, in the Google, so especially if you've never had me before, even if you, and I know Professor Talley does not do this, that's fine. But so even if you took physics at John Jay, you wouldn't necessarily know about this. If you go through the Google Classroom, so all the rest in Google Classroom is all like the homeworks that are due throughout the semester. Everything I'm saying applies to all these homeworks. All of them are all of them are just extra points. Again, just like the other thing, like if you don't do a certain homework, you don't get a 0, you don't get an F, you don't get a punishment. You just don't get those points. Okay. All of these are the kind of points, and some of them at the end, they get big and they're worth like a lot of points. But everything I'm saying about points, anything applies to all of these homeworks. Da, 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 da. Okay. Then there's a section about exams, blah, blah, blah. But then you'll see tools in the Google Classroom. You'll see tools, you'll see our syllabus. It's a little bit more updated, and there's some things that are more clear in it than they were last semester. But you will see 5-step method, example of 5-step, 5-step solution. Like, I mean, the quick and dirty document that quickly just one pager that explains the 5-step method is right here. But then there's an example a student did of like applying the 5-step method to a particular homework. There was a good enough example that I reproduced it here. And then there's a whole long note packet from me going over the first problem of this semester, like, I mean, of last semester, like a whole PDF of me walking through with the 5-step method. It's long, that you can check out there. That's what I'm about to do for you right now anyway, or start for you. But what I mean by the 5-step method can all be found here in tools. I'm going to explain it now, kind of, but you learn it by example, basically. So that's what we're about to do with this first homework. And yes, any homework that has any numbers at all, that's quantitative in any way, it's expected to be done this way. Before I forget, there's a homework due in 2 weeks, homework 1B, that's called Unthingy Things. That is a more conceptual homework. There's no numbers or computations or anything involved in that. And it's kind of more fun and it's kind of relaxing. It's also there because the homework that comes after it takes a long time to do. So whatever, I'll talk about this next week. But homework 2 is long and big, and you may want to give yourself a lot of time to do it. So we sort of tuck in this shorter, more fun assignment in between. So this shorter, more fun, but very important assignment, homework 1B, on thingy things, that one has no numbers or anything, so that you do not have to do 5-step method. And I'll remind you of that when we get there. But you do still have to make a self-sufficient document out of it. All right, but in general, you always do the 5-step method. We're now going to apply that. We're going to go back to the homework we were about to be talking about. This. We're going to apply the 5-step method to this. I'm going to start walking you through. So I'm going to switch the screens back. Okay, right. So is there anything in the chat? Let me just check the chat. I think things are happening in the chat. Okay. I'm going to pause for a sec. So Are we all clear together so far? Is everything okay? Thank you, Jocelyn. Thank you, Gabrielle. Thank you. All right, awesome. Thank you, Judah. Thank you, Justin. Thank you, Jackie. Awesome. Okay, so the one last thing I want to say about the grading of this what I'm about to say now totally was true last semester, but again, I think it just wasn't always as clear as it could be to people. So let me say it again now. Like thing on a spring, homework 1A, it's due at 9, excuse me, it's due at 10:50 a.m. a week from today. What does it mean that it's due? It means that as long as by 10:50 a.m. you have submitted a proper attempt, like a thorough, self-sufficient document that makes the five-step method makes it clear that you're using the five-step method. As long as you like hand in a correctly formatted attempt at the homework by 10:50 a.m. next week, then that means that you're in a position to do as many revisions as you need to if you want. It means you can do as many revisions as you want and take as long as you want to eventually get all the points for that homework. All these homeworks you can get a perfect score on and get all the points, even if it takes you, if you want to, even if it takes you 3 revisions or 3 attempts or whatever, as long as your first attempt is proper and done by the deadline, by the due time. Like, in other words, those portals won't close. If you turn in the homework after the deadline, you still could get points. You will get points for it. Like, better late than never. You certainly will get points for it, but you won't get all the points. You'll get a lot, depending how quick but you won't get all the points. And you won't necessarily get involved in a whole like you won't necessarily get many opportunities for revision and all that. But you'll get credit if you turn it in late. But if you turn in an attempt on time, then you can just keep revising until you get all the points. So it's worth trying and taking risks and getting things wrong. And it's okay to be incomplete on the first one and all that. Just make it proper. The converse of that, I'm going to add one page here. How do you add them? Sorry. Okay, this part's a little bit complicated, a little bit unusual too. This is also a streamlining thing. I'm probably gonna have to say many times, I understand. But as long as you hand in a first draft like on time, you will immediately get more than half the points. Like literally, it might even like you'll literally get a number back that'll be more than half the points. The mere fact that the number is higher than half credit is a signal to you that I know you're on time and I know you're now shooting for all the points. Okay. Like it might come really fast. Like if you turn it in, like it sometimes if you turn in the homework by 10:50, next Monday, you might get like more than half the points back before we even start class, before you get any feedback at all or anything. It's just a communication to say, I got your homework and I got it on time, all and it looks appropriate. Awesome. We're on track. Here's more than half the points. That is a signal. I'm telling you, if I give you more than half the points, right away, it means we're on track for all the points. Now, it might just be that. What I want to make clear is, and that's to keep the process going. As long as you get more than half the points right away, you know you're eventually can get all the points. You might not get feedback yet. You might just be getting those points, and that's not your final score. That is a signal that we're on track for all the points. But then what's going to happen is then I'm going to start going over things in class. Like you'll notice, even with it, you'll notice, and many of you already know, the way we do physics, you have to think about things before I explain them, not the other way around. Especially because I know we're living, like we have the web, we have Khan Academy, we have and the textbook is optional, by the way. I haven't even mentioned. You can get the textbook if you want, but I don't use it. It's optional. There's just way too many resources out there at this point that people are, you can find things out on your own, as you know. So we assign homework, you attempt it, then we start talking about it in class, and then you can, and then you can perfect it and all of that. Therefore, what I'm saying is you'll get more than half the points super quickly. That means you're eventually going to get them all if you want. You might not get feedback right away on your first draft. You're going to pay attention in class. You're going to see what I'm doing in class. Maybe I'll get to things you gave up on, or and you'll see. So then if you start realizing, oh, okay, this is how I do it. Okay, here, then, in fact, I should say this. Okay, so you're turning the homework. You'll get a bunch of points right away. It won't be all the points. And if you don't understand, if you're not hearing what I'm saying now, you at first be like, wait, did I just get an F on it? Like it was worth 50 points and I just got a 26. What does that mean? It just means I'm saying thank you. Awesome. You're on track now. Then we have class. Then I start talking about a bunch of things. Then you realize a bunch of things like, oh, I did this wrong, or oh, this is how I do that part that I didn't understand. Then to save us both time, you don't even wait for me to like you don't wait for the feedback from me or anything. You get it in class. So then you go home and you do a revision for the rest of the points. You upload the new revision by first pressing unsubmit in Google Classroom in the portal. You press unsubmit. That will not take down your draft. That will not ruin your grade or erase your grade or anything like that. It just tells Google Classroom like you're taking, it's like a take back. You're like, wait, no, I want to do something else. So then you attach a new file. Like you attach your new revision. You don't take down the other one. You leave the other one up so I can see how hard you're working, that you're doing all these revisions. You put up the new revision, then you press submit again or whatever it is, and I will be notified. Your grade won't have changed or anything, but I'll be notified there's another revision there. I will take a look. The honest reality is that probably I start putting feedback of any substantive kind once I see the second revision, because I know there's tons that most of you can do from the first draft to the second revision. There's tons of improvements you can make just from coming to class. We don't need to waste each other's time. But by the time you get to this revision, the second draft, now I know you're really serious about this homework. Now I will look, and now I know mostly it's probably really good. It won't take me that much time to find whatever could be improved to give you a perfect score, right? So by the time you get to the second revision, I will look and I'll say, okay, basically I'll tell you what you need to do to get a perfect score, right? So it's a much more efficient thing for both of us. So I'll be like, oh yes, in step 4B, you forgot this, whatever, or you need to put step 4 of the method over here, blah, blah, blah. So you just keep adding new drafts until you get a perfect score. If, I'm looking at the time, this is all if you put something up and then you come to class and you've only gotten more than half the points because I haven't even looked at it yet, really. Then you come to class and you listen to the whole class and you're like, okay, but I did all of that. I don't know what his problem is, but I literally did the whole homework. I did every single question and I think I did them perfectly. I don't see what the problem is. So what do I have to revise? If that's the case, just then take your draft and just re-upload it again. Another copy of the same thing. If you're that confident that there's no problem, just upload it a second time. In other words, I tend to look for the second drafts. It just saves everybody time. Okay. So if you think there's nothing to improve to the second draft, but you're trying to be a student and be with me on this, just re-upload it for a second time. Now I'll look, and if it's perfect, I'll just give you the rest of the points. But if there's something to be done, I'll tell you what to do. Your goal is to just keep uploading until you get all the points. And sometimes it's literally just a game of will between you and me. Sometimes if I'm falling so far behind or whatever, if I see 4 drafts up there and I haven't given you any feedback, that's my problem. And then at some point, I'm just giving you all the points. You either get feedback you either get an instruction of how to get the rest of the points or you get the rest of the points. But now this is easier said than done because eventually the homework piles up and becomes difficult. But I'm saying you have infinite chances as long as you can manage your time to keep barraging me to get all the points. Okay, I think that's clear. I hope that's it's unusual, but the real theory behind all of this is that you should be trying things on your own and taking risks and being willing to be incomplete or wrong and viewing things as constantly subject to revision. And eventually you get all the points as long as you want to, as long as the first draft is on time and proper. Okay, so I think that's clear. Therefore, but leave all your drafts up. Never and don't make the corrections. Again, this is also just practice for journal writing and all of that. If they make revisions to you, you can't just write them in the margin and send them back your original document. You make a new copy, that's better than the old, and you put them both up. So I'm just show where did these? Okay, so. Okay. So now let's get to the 5-step method, right? And let's get to this homework. I think we're on the same page now. So this is now homework. I'm looking in the chat. Okay. So now I'm pretending to be you. I am doing the first homework. So I'm on a separate piece of paper. I'm writing out homework 1A. I don't even really have to put my name because the thing is going to say my name in Google Classroom. And okay, so I'm going to do 2 things now. I'm going to try to start this homework for you to get the answers for you, but I'm also trying to explain the 5-step method as I go. So that aspect will be a little bit boring to some of you, but here we go. So here's my self-sufficient document that's coming. I'm presenting a physics situation here, a physics problem that I'm going to solve. If I do this right and I make a self-sufficient document, what I've really secretly done is I haven't just solved a random physics problem. I'm really supplying a proof or a derivation or an argument as to how this type of physics situation works in general. What I'm really about to do is analyze how masses behave on springs. Okay? So the original problem was that sheet. You notice I'm not even screen sharing that sheet anymore because if I do this right, you shouldn't even have to see that sheet to follow what I'm saying. So step one of the 5-step method of every problem, step one is DFP. What does that stand for? If you look in the Google Classroom, I'll write it once. Now, you don't have to write this every time, but I'm writing it once. If you look in the Google Classroom tools, you'll see that it stands for diagram and fact pattern. So step one is you supply a diagram and the facts. You're going to draw your own diagram. You'll notice sometimes I provide you with a diagram in the original problem, but you're still going to create your own. Can you use a computer to create your own? Sure, but you can't just copy and paste mine. Okay? You're going to create a diagram of the problem. You're going to create a diagram, and you are literally going to label it like step one, DFP, or like say diagram and fact pattern. Like not everybody in the world knows what step one means. You're going to direct my attention to here's my step one. Here's my diagram and fact pattern. So here is the diagram, right? I've got a spring attached to a wall on the left side, and on the right side of the spring is a mass, like a block of mass M. The spring has a spring constant of stiffness K. The equilibrium position of the spring is labeled X equals 0. But it happens that right now, where the mass of the spring is happens to be located or being held by some hand, I should even say, for example, like someone is holding the mass still at some spot that isn't the equilibrium position, some initial displacement from equilibrium known as x naught. I also should put in this diagram, I almost forgot, I'm going to put a little coordinate system in this diagram. Like I'm going to say, from now on, everything to the right is known as positive, and everything to the left is known as negative. Okay, so here's my little diagram. It's similar to the one that was presented in the problem, but it's in my handwriting, it's my style, etc. Furthermore, I should say that some problems you'll see in homework 3, for example, homework 2 is very mathematical. Homework 2 is like the math stuff that we need for this course, some of which is advanced math. So it's very mathy, and diagrams are not presented in the original homework. That's all the more reason that you've got to provide a diagram when you respond to the assignment. So you always, step one is you make a diagram. The diagram should have a coordinate system. The part of the purpose of the diagram is the labels. You're setting the stage for the whole situation. So one thing is you definitely want to label a coordinate system, like what do I mean by positive? What do I mean by negative along each axis? That could be your choice. It may not be. It may be your choice, and you might make a different choice from your neighbor, but you're going to explicitly express your choice. Also notice, notice all these labels in my diagram, like M, K, particularly MKX. Notice those labels, and you may want to write this down in your notes and screenshot as notes that you're getting extra credit for. The labels in the diagram are actually really the purpose of the diagram. You'll know your diagram is complete and is complete if every single variable and constant that you're eventually going to be using in your mathematical solution, in your computations, if every single letter that you're ever going to refer to in your computations is presented right at the beginning as a label in your diagram. The real purpose of the diagram, well, there's many purposes. Partly it's to show this isn't just math, this is physics. We're picturing situations in space and time. That's part of the purpose of the diagram. But another purpose is really the diagram is defining the terms of the computation that we're going to use to solve the problem. So you'll know your diagram is good and ready to go if every single letter that is ever going to arise arise later is actually a label in this diagram. this is all part of self-sufficient document, right? You're not going to, and this really, again, I'm emphasizing this because like this was like kind of a thing on some people's final exams last semester or midterm exams, like where like letters just got sort of introduced and started being used in the middle of their work, but the letters had never been defined. I didn't know, or maybe I knew, but I didn't know if they knew what the letters were supposed to mean. So everything is self-contained and it begins with labeling the diagram with those letters. Okay, so that's what I mean by the diagram, but I call step one diagram and fact pattern. What's the well, notice this, especially for physics 204, we deal with a lot. The math gets heavier in physics 204 than it was in physics 203. And a lot of the math starts looking like not even like math because a lot of the math just has constants and variables, just raw letters in it. If it happens that it's a problem where there's particular numerical values, measurements being given, as is the case here, then that's like a separate line. That's what I mean by fact pattern. Like what I'm saying is notice the diagram. In the diagram, I have things like V and X and K. Then underneath it, maybe I should have done in a different color. Maybe I should have done in a different color. Like underneath, I have, oh, what I mean by, in this case, K is equal to 200 newtons per meter. In this case, M is equal to 0.3 kilograms. In this case, X naught is equal to 0.15 meters. That's an important distinction to make because most of my solution, I'm just going to be doing algebra and calculus and trigonometry with all those letters. And then I'll like plug in the numbers at the last minute. They are not the issue. The issue is the letters. And really, if I do this right, I'm trying to show the world how springs work. And it shouldn't make any difference whether the spring happens to have a K of 200 or of 150. Oh, wait, was it 200 or was it 150 in this problem? I think it's 200. Yeah, it's 200. Right. So the numbers should be like just what happens to be the case here, but not the driving concern. So we distinguish. The letters are the labels, and then the fact pattern is whatever the numerical values and any other facts that might also not fit in the diagram. Okay, so that's step one. That is I'm still looking at the chat. Okay, there's nothing in chat, but we're good. So I'm looking at faces. Okay, so at least we know Gabriella and Jocelyn are good. Okay, so I'm going to go on. That's step one. Whoop. Oh, sorry. The page got out of order 1 second before this. Okay. Okay, so then step two. Okay, so step two, you're now going to present what the question is in your words. And those words could be very simple. Ideally, they probably will be simpler choice of words than mine often are. They might even be symbols. You are going to make the question clear. In this case, the first question is, sorry, in this case, oh yeah. Oh, so it's question one, sorry, not question. Right. Okay. So if the first question is at the moment the mass is released, what force is being exerted on the spring? So you can write. So you're distilling it. You don't have to make it complicated, but you're being complete. Like you can be symbolic. At x equals x naught, F equals what? That's the question, right? You're putting it in your words or your terms. I mean, there's only so many ways to ask a question, but you're not copying and pasting mine. This is a really important step. It's real, partly this is a self-sufficient document. Again, this is what I mean that you're organically, as you go through, making clear what's going on, what your objective is and how you're satisfying it, etc. But also, I promise you, the harder these questions get or the more advanced the physics get, it's such an important step for us when we're solving things to first stop and ask ourselves, what am I actually trying to solve? Like, it's amazing how easy it is to lose sight of a question unless you explicitly put it down. So there's the question. Add x equals x naught. What is f? There's one other thing I was going to say about that. That's the question. I can't remember, but yes, I do remember. Notice that's a question for question one. I'm doing all of these steps for every single one of these parts. When we get to question two, do I have to redraw the whole diagram again? No, 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 no. When I get to question two, when you get to question two, you can say step one, see above. Totally. Like anything, you can do that, but you could do that in a self-sufficient document. As long as you say see above, as long as there's an above to see, you can do that. But you still need to address every single step. You see what I'm saying? We're not trying to make it any harder on you. You're trying to make the life of the reader as easy and inviting as possible. That's really the goal, is make your document something that the reader wants to read and can read or comment on or respond to as quickly and easily as possible. Whether it's me or a journal or a poster, you get the point, right? So, okay, so step two is what's the question? That is the question. Now, so then I guess I'm running. I don't want to confuse. I'm going to go to the next page, even though this is like a lot of wasted. And you're doing this every time, particularly on exams. Step three, GDP. Okay, I got to find a better way to do this. But general definitions and principles. So this is this is where you're going to write down definitions, equations, laws, concepts, things that are, and you may want to write this down here, I'll. This is where you write down things that are, where you write down truths that are known even before you began reading the problem. Notice this this is what we might call, we'll get into generally speaking, these are triple equal signs, whereas the other stuff from step one were double equal signs often. What I mean by this is this, and I'm watching the time. Okay. What I mean by this is, a question. I think I just heard a question. Sorry, wait, who is that? Wait, I see Jay, yes, Jay, please go. Yes.
So, I think that you're probably about to explain it, but I just wanted to make sure. So on the document that you have for the 5-step problem, there's a side note that says we proceed true and relevant, not the other way around. So you mean facts before definitions?
Wow, you really good for you. Oh, there's got to be a portal for what you just did. Yeah, great. Thank you for like checking that out and cross-referencing. Okay, so yes. Okay. I mean, two things. One thing bear with me for a second. I'm going to back up on your question for a second, then I'm going to hit it. One thing I want to make clear to everybody, because everybody's been showing their work in one way or another since 7th grade. I know this. And I know that in 7th grade or 6th grade or 9th grade, we all kind of learn, like, write down what you know first and then figure out what you're trying to figure out. Like, write down all your knowns first or your givens and then figure things out from them. We all kind of, I think, know that in some. What I'm trying to say here first is there's two different types of knowns. And we want to keep them separate. Part of why people struggle with problems or knowing how to begin problems is they often don't realize that there's two different kind of knowns. In step one, we're presenting what's known from the problem. the step one, and this is not Jay's question yet, everybody. I'm backing up on Jay's question, then I'm gonna, but it's a great segue. In step one, you're telling the facts of the particular situation. There's this mass, there's this spring, blah, blah, blah. But then step two, you're like, so here's what I want to know about this situation. Here's my question. Now in step three, we back up and we say, what do I know about life, about the universe, about space and time? What do I know about physics that I just know, but that's going to help in this problem, right? So step one is the knowns of the problem. Step three is the knowns about the universe that you knew even that would be true, even if we didn't have this problem, but now are going to help us with the problem. Equations, laws, etc. Now, to Jay's question, part of what I'm getting at here is part of why we're okay. So, I'll example was right here. I would write something like this. Still have not answered Jay's question. I'm aware of that. I'm about to. It's great. Hold on a second. So for example of step three right here would be writing down Hooke's law for the force exerted by a spring on some mass touching that spring, and the law is F equals negative kx. Like I would write down something like F equals negative kx now. Now here's what I'm saying to Jay, the true relevant thing that Jay's talking about. There's many reasons to do that, and this may not be also, well, that's not the only, that's number one. So sorry. Like I would write that down. Oh no, yeah, that is all I'm gonna write. Yeah, that's what I'm gonna write for this. The true relevant thing that Jay's asking about. One reason to do this in step three, before we go any further, is that what many people do when they're stressed or anxious or panicking under time pressure in the middle of an exam, what certainly used to happen to me, even when I studied or I thought I was being a good person or whatever, but I was in the middle of an exam and I had a hard question and I started panicking. So what I would unconsciously do is I would scramble to write things down that I thought were relevant. I would think like, what is this question like trying to get at? Or what does the professor want? Or like, what did we just study last night? And I would like write down things that seemed relevant. And then I would use algebra or trigonometry or calculus or something to like change both sides of the equation and do stuff, manipulate the equation and the statements until they seem to become like true. I'm not saying I consciously thought of this. I'm telling you after years and years of experience that when I was under pressure, and I don't think I'm the only one, when I'm under pressure, when science students are under pressure, what they unconsciously, accidentally, and legitimately do is they write down things that are relevant and then they try to use math to manipulate them until they're true. What I'm saying is a much better strategy that takes practice. It is not obvious or automatic. A much better strategy is, especially if you're panicking, is no, just write down things that are true and then use math to try to make them relevant. The fact is you can't turn something that's not true into something that's true, but you can turn something that's true into something that's relevant. So what I'm saying here, and it sounds obvious in a way, but I'm telling you, it's not what happens when so what I'm saying is, this problem I'm dragging out, I'm using this first exercise on your homework as an example of doing the method because I think it's not the hardest exercise in the world. You can see the method in an exercise when we're calm and it's not so hard. But this whole method is really designed for what to do when things are hard. So I'm saying like a lot of people could probably get the answer to the first question in their head, but let's drag out what steps are happening super quickly in their head. After we did step one and presented a diagram. And after step two, we said, here's the question. The question is, what's a force being exerted by this spring? So then in step three, what I want to do is just write down anything that is true about spring forces. I'm not going to get myself stressed yet about if I know what to do with those truths. I'm not going to worry yet if I know the math or if I can handle the math. I'm not going to get stressed yet if I have all the values even. I'm just going to write down something that's true about springs, which is this: Hooke's law, F equals negative kx. Sidebar, I'm kind of assuming that most of you have seen F equals negative kx in Physics 203. I am assuming that for the moment. But if you haven't, I'll back up or you'll talk to me privately or whatever. But this is a thing, Hooke's law. It's a physics statement. It's a physics law. I'm saying I would write this down right now before I worry about if I know how to use it properly. I just know it's true. So I write it down. And then in step 4, in a moment, I'm going to start to plug in values, see if I have the values and plug them in and do the math to get to my final answer. What I'm trying, but I know I'm taking a long time on this, but I'm just so glad that Jay did that she like cross-referenced over there and asked the question. I am telling you all, unconsciously, when we panic, the accidental thing we do is we scramble to write down things that are relevant and then we try to make them true. The real strategy that will get you better and better at physics and will get you better and better at handling situations where you don't think you know what to do, the better strategy is just write down crap that is true and then work to make it relevant. Don't get ahead of yourself and worry if you know what to do with the truths. Just write down the truths. Last thing on this, I'm not upset, I'm just excited. Last thing on this step method that I'm giving you all, and again, I know I'm boring some people with it. I know, and I know some people hate, but the thing about the step method, besides the fact that I really believe it really makes you smarter at physics, like to get used to doing this, and it's annoying when you already know the answer. But if you don't already know what to do, it gives you something to do. And I'm telling you all, not only is it a larger, just good strategy, but it is my grading rubric. It is the grading rubric. And most of you did really pick up on this last semester, but it's a grading rubric in the sense that that I'm looking when I take your documents or your homeworks or your exams, I'm looking for the steps. I am looking for the steps. And on the one hand, the first way to lose points is just if I don't see step 2, I'm just going to write WIQ -2, whatever. And I expect you'll know what that means. If you're missing a step, I don't care if you got the answer in your head. That's an easy way for me to take off points. But conversely, every time you do a step, you're getting points. You're getting points. So to write down a truth about Hooke's law, even if you don't know what to do with it, even if you make a mistake doing something with it, if you've written down something that's true, it's true. So you've already by step 3, you're 60% of the way into the problem. You've already gotten 60% of the points in effect. So it's good for both of us. So I'm saying just write down things that are true. If they're true, I've got to give you credit for them. And so if it was a journal article, the person reading would be like, yeah, I'm with you. Okay, right? So you're just building truth. So, okay, that's like my long answer to Jay. So Jay, if you want, you could put in the private chat if I did answer your question or not. And if you do put in the private chat, like, yes, that answered my question or whatever, that's a portal. There's a portal called Closing a Conversational Path. Everybody, there's a portal called Closing a Path. It just means like if you just send me a signal that like you're good and I'm good and we can move on, and you get points for that because it's to the benefit of the whole class. But if you're not good, then I want to know, so I'll answer it differently. You could also put in points for please move on, please go forward, which I will in a minute. But it was a great question. But what I am trying to tell everybody, if you don't know me, is you just do this. This is how you bit. Because what I really know from experience is when you look at a problem and you think you don't know what to do, this is giving you things to do when you don't know how to do that will get you closer and closer to the answer. If you do them, you probably will get the answer. But even if you don't, you've done so much work already, you're getting most of the credit. Notice, I'm going to move on now, I promise. Notice, we're already at step 3 out of 5, and we haven't solved anything, right? We haven't solved anything. We haven't plugged in any values. What that means is you can get through a lot of work without actually knowing what to do. That's the point. That's how physicists work. I'm going to now do step 4. Okay, but the converse of all this is why am I putting you through all this? Because I think we all do know we've all been in college and science long enough. I'm just going to say this once. No, I'm not. I'm going to say it a million times. generally speaking, people watch me do the problems in class or SWAT, and they're like, "Oh, I get it when he's doing it. Oh, I get it. Oh, I can do the math. Oh, I see that math. Oh, I can divide both sides by 3. Blah blah blah." But what people will say is, "I can do the physics. I can follow it, but I just never know how to start." That's a real issue with everybody. It's like you can do the problems, but you don't know how to start. Right. So I'm telling you how to start. Like how you can get rolling, it's all of the hard physics problems really are about the setup. If you set up a problem correctly, then you just put money in the machine and the machine cranks itself. The question is, did you set up the machine correctly or not? So how do you do that? You set up solutions with step 1, step 2, step 3. They're really boring and annoying if you think you already know what you're doing. But when you don't know what you're doing, they're a lifesaver, and you can't build a life raft out in the middle of the ocean when you're already drowning. You got to build the life raft on land where you're comfortable and then bring it out with you to the water, right? So that is step 3. You write down the law F equals negative kx. That's the relevant law here. I mean, that's the law about springs here. So then I'm looking at okay, so then we go to step 4. No, I've already lost somebody on that. So I knew it was going to happen. Hello, hello? Come on. Okay. Step 4 is PAW, which means particular application and work. And this means all the values. This is the plugin part. The values, the computation, all the trigonometry, the calculus, the algebra, all the stuff will happen now in step 4. The units, keeping track of units. Step 4 is now what most people consider showing the work. This is the part where you do the work, okay? But I'm telling you again, I will shut up, but I'm telling you again, the real thing of this whole method is step 4 is mistakenly where most people try to start. And that's why if they know what's going on, they just dive into step 4 and then they just do it and it's over and they don't even know why they had to bother to show work. But if they don't know what's going on, they try to dive into step 4 and then they're stuck and they say, I have no idea what's going on. You can do step 4, the classic showing your process, if you first set it up with steps 1, 2, and 3. But now we did. So now we can say so now we're going to the particular problem. We're taking this general principle from step 3 and we're applying it to the diagram and question of steps 1 and 2. So we say something like, to transition us from general to particular, we say something like here, K equals 200 newtons per meter, right? And X, the initial X naught, sorry, equals 0.5 meters, right? So here, therefore, if F equals negative KX, F equals negative 200 newtons per meter times 0.15 meters, right? Like, so I'm doing the work. Oh, I'm looking at sorry. Sorry, wait, I'm looking at the chat and I'm also looking at the time. Did I do the wrong question? Wait, since Hooke's law is in newtons per meter, right? Should the mass to solve the... Oh, yes. Okay. Oh, sorry. So this is a question. I'm not reading the person's name because it's a private chat, but person's legitimately asking many questions. Wait, since Hooke's law is in newtons per meter, good. Should the mass that we need to solve the acceleration in question 2 be in kilograms? Yes. By the time we get to question 2, so I'm on question 1 now. When you get to question 2, yes, I would convert that mass to kilograms. Yes. Yes. I'm not. I'll leave it at that. Yes. Your answers, unless specific. Your answers on you yes, I'll just leave it at that. Yes. Okay, fine. Yeah. So yeah, convert it to kilograms. Like you want to be in SI units when you can, when you can. Yeah. Um, and then also for step 2, do I want us to include the hints? Sorry, I'm reading this out loud. For step 2, do I want you to include the hints of the last problem when writing the question? Oh, but no, that's a good point. When you do step 2 and you capture the question, if I happen to have given you hints, yeah, that's dialogue between you and me. You do not have to recapture those in your presentation of the question. Again, that's a very good question. And both of these were very good questions. The standard is like you're sort of in the back of your mind with your homework and your exams, you're trying to do two things. One, you're really trying to make life as inviting and easy for me as possible. Like you're trying to rage against the machine and get it so that I don't take as long to return things to you. That's part of it. But the other thing is in the back of your mind, you're thinking like, what if I were submitting this as a journal article? So the hints I'm giving you, that's not necessary to the question. That's just helpful to you. So no, you don't have to include those in where the hints will come into play. It's not that they'll definitely come into play, but you'll incorporate the knowledge of the hints, like either in step 3 or step 4, depending. They are information that you'll use, but yeah, they're not. Okay, I think you understand. Okay, great. Okay, so here's step 4. And then finally, step 5. Step 5 is FAC, which means final answer circled. And circled could mean circled or bold-faced or highlighted or boxed. But really, the final answer, you're going to present the final answer, and you may want to write this down. You're going to present the final answer in a way that offsets it from the rest of your work. Like again, you're trying to make life easy on the reader. And you're also trying to make it clear that you know it is the answer. It's not just more information. Like you're landing the plane. You're showing there was an original research question here. Again, imagine this is an article or whatever, a paper. Like there was an original concern here, and then I went down this journey with everybody and showed why everything I'm doing is legitimate and self-consistent and true. And then I got to the end of the journey, and here's the end of the journey. And like I'm telling you, like this is the end of the journey. Like I'm not confused. I know what I'm talking about. So that means number one, it's going to be, and you want to save like honestly, a journal reader or me, I'm going to look at your original question. I'm going to first look to see if your answer is correct. I mean, in my mind, I'm going to like look to see if they have a clue and look at the answer. Then if there's an issue, I'm going to look in between. How did they get? Like, where did the mistake go? But first, I want to see, I'm zooming out and seeing the whole picture. So yes, circle your answer and make it easy to find. I'm looking at the time. Okay. But again, yeah, circle could mean box or highlight or something. But also the answer is a complete statement of truth that addresses the original question, i.e., in this case, the answer is, and maybe I could do one more. Well, no, so I do the math. Maybe there's one more step here of the math. Multiply 200 by 0.15. Obviously, cancel out. Cancel out. Yeah, I would cancel out these units, right? And I do the math. And so the final answer is at x equals x naught, or in other words, at 15 meters. You could write it either way. At that position, F equals negative 30 newtons. This is my final answer. It is a statement. Notice this. I mean, So my final answer is a complete statement. By complete statement, I mean like subject and predicate. I mean an equality. Not my final answer is not 30 newtons or negative 30 newtons. My final answer is F equals the value of the force, the measurement of the force is negative 30 newtons at under the condition of X equals 0.15 meters. Like, so it's a complete statement with units, with a negative sign in this, with direction. I mean, if it were a vector, it'd be more complicated direction, but whatever. So a complete statement of this equals that under this condition, and the complete statement wraps me back to the original question of step 2. The whole thing is a package. Step 1 is a picture. Here's the deal. Here's the scenario. And then step 2 is like, what's up with that scenario? Step 5 is this is what's up with that scenario. And steps 3 and 4 are how I got there. Step 3 is general. Step 4 is particular. I mean, this is like the logical structure. Now, if you go to another class after this, like PChem, I'm not saying that, Dr. Petracco is going to have the exact same step method or whatever. Or if you do submit a paper to a journal, I'm not saying that all journals follow this exact thing. But what I've found in my experience is that every professor, every context, every conversation, every journal has some kind of built-in structure of expectations. The reader comes in expecting a certain kind of or like if you had Dr. Domachevsky, methodology, then oh my God, I'm like data collection, then analysis, whatever it is, it's different. The structure is different from environment to environment, but it's always very similar. And the point is that once you're in an environment, the structure is expected, and that's what the reader is reading with a certain structure in mind. So you first and foremost just want to say to the reader, I'm with you. I'm on the same page. Here's my structure. I'm conforming to the structure. Now that you can read fast because we're on the same structural page, here's my substance. And I feel like for physics, this is this is the structure I'm used to. So do this. Excuse me, we have like 2 minutes left. I just dragged it. Now, I know that many of you could have gotten this first question in your head without all this. I understand that. But by the time you get to question 9 of this homework, it's hard. Most of you have not seen how to do question 9 before. So I'm asking, do this for every single question on the homework. Do your best attempt by next Monday. You don't have to keep repeating the diagram or anything like that, but just keep doing this. Refer back to your old notes from Physics 203. On energy conservation and things like I'm telling you right. Oh, we have 2 minutes. By the time you get to question 4 of this homework and question 5, definitely the way to solve those is F net equals ma, and forces won't be enough. You'll have to use kinetic and potential energy. By the time you get to question 4 or 5, that's a hint. Like, use energy. Now, are you allowed to help each other? Yes, absolutely. Are you allowed to go to the MSRC? Absolutely. Are you allowed to go all over the web and even use AI and all that stuff to get help? Yes, we'll talk more about AI next week. You can do whatever you want to get, certainly Khan Academy, I'm a big fan. You can go to any resources you want to get help on this. But at the end, you present your work this way and you make your best attempt. And by the time you get to question 9, I'm telling you right now, if you're honest and you don't use AI in a inappropriate way, you probably won't. You may struggle with question 9 and you might not be able to finish it. And it'd be very honest and fine if you didn't. It would be, in fact, suspicious if you just nail question 9 with no issues whatsoever. That would be a red flag, to be honest. It's okay if you struggle with question 9 and you don't finish it. But what you'll see is by the time you get to question 9, if you've done this method enough on the easier questions, by the time you get to question 9, even if you're struggling and find it hard, you'll be able to get at least somewhere into step 4 of question 9. You'll at least know how to start, and you won't be able to say, I have no idea. You'll have an idea. Yeah, it just might be a hard idea, and you might not finish that's okay. But do this method each time. This is what I'm looking for. So just do your best attempt to do the whole homework this way. Turn it in by 10:15 Monday, and you'll be, no matter what points you get right at that moment, you'll get all the points later if you want to. It's now 1:30. Oh, sorry. Wait, it's 1:30, so I'm gonna stop. You can go. I don't want to keep you, but I am gonna answer Jay's question, and I'm gonna hang around for any questions. I'm gonna stop the recording and hang around for any questions. So you can hang around too, or you can go. But it's great to meet you all or see you all again. I will see you next week. But Jay, I'm going to answer a question. Oh, and anything in the chat, I'm going to answer. So hold on. But you won't be rude but if you are going to go, say goodbye or something, or write goodbye in the chat. But these questions might help you. So if you have a minute, you might want to hang out. Wait, first of all, I see the thing in the chat, but Jay, go first.
So that one of my questions was in the chat. I asked if you wanted us to explicitly number like which step we're doing when we're solving problems.
Great question. Yes, please. Fast answer is yes, 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 please. Great. Yeah, great. Thank you. Okay, great. Have a good day. There was another question in the chat. Let me see. Does the answer? Oh, yeah. Great question. So someone asked in the chat, would your answer differ depending on how you would dictate the signs of this problem? Okay, great question. This is where the coordinate system of the step one comes in. So I labeled to the right positive and the left negative. You could do the opposite. You could call left negative, left positive and right negative. Total, as long as you labeled it, that would be fine. But now two things, and sometimes that would mean some of your answers would differ. And that'd be fine as long as you were self-consistent. However, note two things about that. If you make a different, my choice wasn't the only correct one, but it was a pretty convenient one because X naught, where the mass originally is, I call that positive. If you call the side where the mass originally is, if you call that negative, then X naught really is negative 0.15, right? Like, which I think is a little bit inconvenient, but it's totally fine. But if you do the other choice, then X naught is negative 0.15, and that's fine. But the law, Hooke's law, is still that F equals negative KX. So even if you put, so this is what you're saying. Sorry. So then you would put negative um, uh, 0.15 in for X. So then your force would negate that. I mean, it's negative KX. So your force would then come out positive. And you're right. And that would be fine as long as I saw what you were doing. Your force would come out positive. Let's both realize, though, that no matter how you slice it, for both of us, our force is coming out in the opposite direction from the displacement. Like in either case, the force is pulling the mass toward equilibrium. So if we wrote it in English, which wouldn't be a bad idea, both of us would be saying force is 30 newtons directed toward equilibrium in either case. But yes, it could be actually a positive number as long as X naught were negative, as long as you're consistent. Yeah, great question. Have a nice day. Have a nice day. Okay, great. Did that? Oh, great. Oh, cool. Awesome. Great. So thank you all. I'm still. Any other question? Or Jay, you're good? Or Justin, Brianna, and Angel, you're all good? Or
Good. Yeah, that's
Yep.
it.
Have a good
okay.
day.
Have a good one.
Thank you so much. Have a great day.
All right.
Thanks.
Yeah, I'm good. Have a good day.
Thank you.
Good to see you.
Great. You too. Thank you. You too. You too. Great.
Bye.
Bye. Okay. That is a wrap with Caesar dressing.